Hey everybody, welcome back to the channel and thank you for watching and subscribing. So we're still back working on the Land Rover GM Scotty swap and the old Land Rover Discovery, not Land Rover Discovery, Land Rover Series. So this video, if you didn't think I could make a boring video, I can make one even more boring. So enjoy this video. So this one is going to be all about measuring. It's going to be measuring the Land Rover Flywheel. I wrote down everything. The Scotty Adapter with the GM engine, so we can get all of our, so we know where our clutch is, our flywheel and everything. Our GM pilot bushing, GM flywheel, and there's going to be lots and lots of numbers. But I want to give you an idea of what you're going to need to do to make the adapter, the engine, the GM engine, and or Mercruiser engine fit into the Land Rover transmission. So there's going to be a lot of measuring and a lot of different things. So a lot of things you're going to need to do on your own in your own engine. But I'm going to put out some numbers out there. But again, they're all up to you to figure it out on your own. So thank you for following along. If you make it to the end of the video, it'll be amazing because it's a long one. But thank you for liking and subscribing, and I'll see you at the end. Here are the two engines here. So we have this one, the GM with the Scotty Adapter over here. We're going to have to measure up our crank end here to see how our flywheel will fit. And this is our Land Rover one over here. So we're going to take some measurements from the stock Land Rover to find out where our clutch needs to be for the Scotty Adapter so we can get the flywheel machined. So let's go down and we'll start measuring this and we'll see what the offset is. So here we are at the Land Rover with the clutches taken off, of course, you can see. But here's the studs that we're holding the flywheel on, not the flywheel, but the clutch plate. So what we want to do is we have our bell housing here, and this is our flywheel, of course. But we want to measure this distance, this surface, to the flywheel, so we can get our Scotty Adapter, get our flywheel measured out right. So I bought this tool. It was pretty cheap off of eBay from China or somewhere. So it has a veneer scale. I'll show you some more of that later. But what I'm going to do is I'm going to put it flat against here, hold it flat, and then push this in until it's flat against the flywheel as well. So we're kind of squaring it up with this surface and this surface right here. So if we square that up, you can see, I'll bring you in closer, but I'll show you, but if it's flat, you should be able to get yourself a distance from that end surface to there, okay? So then over here, do the same thing. We'll flatten it out and push it against it, and we'll get a measurement right here, okay? So let me show you, I'll bring you in closer and I'll show you that. So here's our tool here. So we take this, we make sure it's flat against this surface here, and flat against this surface. When you're looking down at it, you'll be able to see that it's completely square and flat on there, so you can get your measurements on there. The measurements we found, what I found was from this surface to here, and from here to here, it came out to 0.492 to 0.50. So it's actually about a ½ inch from here to here. So your flywheel on your Scotty has to be, your GM engine needs to be a ½ inch for the stock clutch to work. So we know that number now. So let's go over to the GM one and we'll do some measurements on that next. Now we're over here at the Scotty Adapter on the GM engine. So we have to measure this out here. I measured the bolt pattern on here, or the size of this, just to confirm that it was a Chevy V8 pattern, which it actually is, but you'll need to confirm that, which I'm sure it is, because if it's on here, then I'm sure it's a Chevy V8, early V8, or a 350 small block Chevy crank pattern. So we have to measure from here, from our surface here, from here to the surface of this here for the end of the crank to get our flywheel cut to the right size. So what I did was I put a straight edge through here. I'll show you that in a second. A straight edge from here to here. And then I measured the depth. But I'll show you that in a second. But before I set up to there, we also have to figure out our pilot bushing, okay? So what we need to do, what I did is I literally just took the calipers and I measured our thickness right here, which we have that number. We have it written down here on a piece of paper. I'm going to show you that. And then we have the diameter here, so we know what that is. And we know we can measure our depth from here to here to this surface. Okay, so we know the thickness that we have right here to use. So for the pilot bushing, we know the diameter and this little depth that we have to work with to make our pilot bushing work. So now, let me set up real quick for the depth, how I measured it. So what we have set up here now is I just used this piece of angle iron thing. I'm not really sure what this is from. I think it's for like garage door or something, but it's pretty flat though. It's not bent or anything, so it's got a good straight edge. So what I did is I took our calipers and I measured the thickness. So we have our thickness of what this surface is right here, okay? Then I took our handy dandy depth gauge and I slid it in to get our pilot bushing total depth that we have to work with, okay? The next step was I come out to this surface. Let me see, can you see that? Okay, yeah, you can see it. Okay, so this one now I measured from this surface to this surface right here. So then, again, we can see where our pilot bushing will fit inside that space. The next one was this space right here. Then I went in there and I measured that like that. So then we know our distance from here, which was the surface of our Scotty adapter here, to the surface of here. So we got all these dimensions, all these depth dimensions that we have, okay? So then and then we'll subtract the distance or the thickness of this metal, and it'll give us our distance from this surface to this surface, this one to this, and so on. So that's how I got all the depth dimensions for this engine and the adapter. So then we got to use these numbers to figure out our clutch and pilot bushing. So let's measure the pilot bushing on the Rover engine. I forgot to do that. So we're going to measure the pilot bushing, just the idea of this bushing. So what I did is I took a pair of calipers, and it's kind of a tight squeeze to get in here. But I got that number, and I wrote that number down. So then that'll be our ID, or at least give us an idea on how to cut the pilot bushing. Now we're over here at the transmission. There's a lot of measuring going on here. So we're here at the transmission, but we need to get some numbers for here so to figure out where our pilot bushing is going to ride and where this input shaft is. This is, I wanted to know where this was, the diameter of this, and where the surface of this runs into the end of the pilot, not the pilot, but end of the input shaft to this surface here. And also I wanted to know, there's right where the clutch goes into these teeth going around. I wanted to know where the depth was to there, to the end. And also there's a wear mark on here. Let me show you real quick. If you look here, that's where the pilot bushing was actually running right here. It was actually rubbing right against here. So we have a measurement from the end of here to where the wear point is. And it's just to give us an idea of how far in this was actually riding into the pilot bushing. So let's go back here. So again, I took the calipers, measured the thickness here, measured the thickness of our splines here just as a reference. Then I took on the other end of the tool, there's actually a depth. So I took the measurements from the end here to where the teeth start, and then from where here to the wear point of the input shaft. So we got these numbers here, okay? So now we need to know this surface here, or even this surface here, like right where the teeth start, right into this area, is relationship to the bell housing, this surface right here. So what I did is there's a depth, there's a lip that comes around. I'll show you here. See the lip right here? It kind of, you have to measure the depth of this lip to here. So then what I did next, I put a straight edge across here, right across like this, and I measured from that to the end here to this surface as well, the end of the input shaft to this surface, and then I subtracted it, and it gave me the numbers to go to the bell housing to the input shaft. So then now we know where all this is sitting in relationship to this, that, and this, that. So, okay, so the Land Rover transmission can now be sketched out. So you have all these numbers, so what do you do with it, right? I know this video is a lot of talking and a lot of jibber jabber, but it's all informational really for the next person that does this. So you have our sketches. Here's all of our numbers we wrote down, that I wrote down here and there all around. But these are all numbers that you're going to have to do on your engine and confirm everything on yours before you do any machine work or anything like this. And if you're following along and you're looking for like a Scotty adapter and you do find one, you're going to have to confirm all of your own numbers on yours. So I really don't want to give you too many numbers, but I can give you a little bit of an idea of some of the numbers. But you're going to have to confirm it on your own, okay? I can give you kind of guidelines, but don't take my word for anything. So you should always measure your own stuff before anything, okay? So we got our numbers here, okay? After my little spiel there. So we got our numbers. What do we do with it? So what do we have to do with them? We actually sketch them up. So me being mega analytical, and I don't know what I do or whatever, but I have to think about things 100 million times. So what I did is I actually sketched it out. So here I have the Scotty adapter here with my numbers here that I took off my paper drawings that I made it a little sketch up on it or whatever. So we have our GM Scotty adapter here with our measurements. We got our depths, we have our sizes, we have our diameters going around for our end flange here, the crank itself. And then over here, we have our little one here where I have like the diameter. Also, this is a cross section looking through everything. I'm sorry, I should have said that. But cross section going through everything. So over here we have our Land Rover input shaft and our sizes, the diameters, and so on and so on. So we have this as a reference, okay? So we got this, our Land Rover assembly, our Scotty one over here, right? So let's put them together. So right here in the middle, I took this one, slid it over. I took this one, slid it over, and I put the two bell housings put together right here, okay? So then this gives us our numbers for our pilot bushing, which is right here. And then our clutch, which is right here, actually our flywheel here, okay? So now we have these sizes and numbers and they're all put together, okay? So up here we have, I don't know, you probably can't see it because it's small writing, but it's a 1/2 inch is what we figured out where our clutch flywheel face needs to be, okay? So we're at a 1/2 inch from here to here. So then that gives us our numbers. So then from this surface to this, we know we need to be a certain size, okay? So that's how we figured out our flywheel depth that needs to be machined. And the next thing was our pilot bushing. We have our sizes here. It'll give us our OD of the pilot bushing. Then the ID over here of the pilot bushing will give us our size of the pilot bushing. So for a pilot bushing though, you need to have your ID. You got to have some play in there because it's not meant to be tight fit onto this. So there's also a value you can use for that. So you're going to have to Google that and figure out your own numbers. But I figured out my own. But I'll give you the numbers, but it's up to you to decide what you're going to do. So here, there, that's into there. So then we know how big our pilot bushing has to be. And now we just figured out where our clutch needs to be, okay? So I took these, and I took these things and I made a little drawing. So I made separate drawings of each. So the sketches that we have is the first one is we'll take a look at is the pilot bushing. The pilot bushing itself is actually a press fit into the crank, and this is the size I got. It was 1.706 diameter at the end of the crank that the pilot bushing presses into. Okay, so we know we need to be just a smidge larger than that. Okay, so then we know from measuring our input shaft of the transmission, which was, what did we get here? Let's take a look. I got it to be 0.874, okay? So what I did is I actually added on, again, these numbers you're going to need to figure out yourself, is I made it to this value right here, okay? So that value there, that's big enough. It gives us some play on the pilot bushing, and measuring also the used pilot bushing inside the engine, the Land Rover engine itself. So I kind of used that number in our actual measurement and kind of eyeballed it and got it kind of close to the number. So I got it to 88 to 890 basically is our ID of our bushing. Then the OD of it, outer diameter, I made it 1.707 to 1.708. So you really want to get as close to 7 as you can, so you only have a little bit to press it into the crank. So I took these numbers here that I know that I need, and talking to another fella, I'm going to give him a shout out. He has another Scotty Adapter, and he actually sent me an email, and we talked for a little bit too, and he measured out his pilot bushing in his engine that he has. So big thank you to you for doing that, and I really appreciate that. Thank you. So what he did is he found, and also I confirmed the sizes too when I was looking around, is he had a pilot bushing in his Scotty conversion that had a different number to what I found, but this is the one that I used. I think I can't quite remember what numbers he gave me, but what I did is I used the standard bushing. It was PB-50-D. So if you Google that, or if you put it in eBay or something like that, it'll come up with a pilot bushing. And the pilot bushing will look like this, okay? And the sizes of the pilot bushing is 1.851 and 0.669 and 0.53. This is actually what it says online. So here, so how do we know this is going to work? We know our OD is that big, right? And we only want it to be that size. So that gives us plenty to machine off to get down to there. ID, this number needs to be smaller than this number, so that gives us plenty to machine off to get to that number. And the thickness itself, I didn't change the thickness. I kept the same thickness as it was for it, so whatever it is, that's what it is, and it should give us plenty to ride the input shaft onto. So I took this, I bought 2 of them. I bought an extra one. I bought a couple of these just in case the machine shop screwed up on them. So this is the finished product here. So what do we got? After I took it to the machine shop, they went and got it, and then they machined it down, and we're at, let's see, I wrote down the numbers. OD is actually 1.707 is what I came up with here, is the final product is that size. The ID here, I just took that and measured that out, and that came out to 887. So the pilot bushing is all good. We're within our tolerance here. We're pretty close to here as well, the 6. So the pilot bushing should be good. So let's go over to the engine. We'll toss this on real quick just to see onto the input shaft and see if it fits on there. Let's see here. See that? Gives us plenty of play, but it's still loose, which is good. You want some play in there so when it heats up, it doesn't get snug or anything like that. So there you go. So that fits onto there. Let's do a quick little fitment with the Chevy engine. And that kind of gets pretty close right there. So that's a snug fit. So I'm going to freeze this and hammer it in. Just hammer that right into there. So it actually sits in there nice. So pilot bushing's good. So that's all done. we're going to talk about the flywheel, what kind of flywheel you need for the Scotty swap. So this is a Chevy 153 flywheel. It has the bolt pattern that fits on a Chevy V8 or the inline sixes or the 4 cylinders, just the same as what we're building. So this one's actually from a Mercruiser engine, and you can see it's all painted over because on a Mercruiser there's no clutch, but I think they use these bolts to hold on to the stern drive. So all they do is just paint right over top of it. They don't machine it or nothing. All they do is use these bolts for the run the stern drive. So I picked this up off of eBay pretty cheap. So to make sure you get the right flywheel, that's mainly what we're going to talk about. So the teeth going around is a 153 tooth because that's the same as our starter, and it'll fit within our adapter. And this is unmachined. This is exactly how Chevy made it. So it's very interesting that Chevy made this flywheel, and it's the same bolt pattern going around as the Land Rover. So let me show you here. This is this is the one I took off the truck, the Land Rover, the diesel version. I don't know, I think it's original one. It says made in England and everything with the old school way. There's some numbers on here. Actually, it says here, made under 1 or more, blah, blah, blah things. And the part number is 368537, it looks like, right here on there. So, okay, so again, like I said, this is a Chevy flywheel. So look, this is awesome. You put this on here, and it's actually the exact same size. I'll show you an aerial shot here. The bolt holes line up for all of the bolts going around. All of your bolts going around. So the flywheel is actually already drilled. It must have been a standard clutch back in the 60s or whatever to have that bolt pattern. So let me set you back down here. And so our clutch pressure plate matches right up to the holes. So our clutch disc right here, which measures, let's see, I measured everything out here on this piece of paper. So the disc itself is 9 1/4 from here to here, diameter. Then this groove here for the original Chevy clutch is from the edge here. Oh, I can't even see that. Hold up. So this edge here, it comes around in this groove. To this edge, to the other side edge over here is 9 1/2 inches. So I'll show you here. You put our Land Rover clutch disc on there, and look, it fits right within that groove on the flywheel. So that's good. This is coming out to be very nice, working out so far. So, so the groove here, and these bolts line up. So let's talk about some numbers. Like I said, this is 9 1/4. The Land Rover disc is 9 1/4 inches in diameter. The groove here, from here to here, is 9 1/2 inches for the disc groove. That's why I just called it a disc groove. I don't know what that, I guess that is a groove for the disc there, or at least for like the dust to come out. And then there are 6 5/16 holes. They're already tapped for 5/16 18 threads. They go into here, which was the same size bolt that I took off the, well, these are actually studs. So they have the same size bolt hole. And then the bolt circle going around here for the threads themselves. How about that? There you go. So this here, the center of that's 10 1/2 inches in diameter, the bolt circle going around. And like I said, it's a 53 tooth here for your starter ring. And your diameter of the whole flywheel itself is 12 1/2 inches in diameter. So what I'm going to do is I'm going to take this to the machine shop. I did all the measurements on the engine. We're going to go over that. I don't know if I did or not yet in the video, but I'm measuring from the back side here underneath to this face. It has to be a certain distance, and this is where you're going to have to measure your own engine to see how that goes. But we'll talk about my engine, but then you find out your own numbers. So I'm going to take it to the machine shop, and they should be able to machine this down to the thickness that we need so we have the right size for the clutch to activate with the Scotty adapter and everything. So I know this is long-winded, but I wanted to show you everything. So if you get a flywheel that looks like this, where it's kind of close where the size is, where this kind of steps in like this, and you kind of have this size with a 153 tooth, you should be able to have it work. But also, caution, if I find a picture, I'll put a picture up I'll put a picture up. There is one that has these just a little bit further out. So it's for the 10-inch clutch, so which is for a bigger GM Chevy clutch. But I would imagine that a machine shop could put drill and tap. If they're going to be machining this off, I'm sure they can drill and tap for the clutch that you need for the bolt circle to go around. So one other thing is I'm going to ask the machine shop too if they can do this. On our original Land Rover one, there's dowels right here, 1/4-inch dowels. Well, here, let me flip it. There we go. So we have 1/4-inch dowels right here and right here. I'm going to see if they'll be able to machine and put those in as well. Because then if we use the dowels here and we have our bolts here, that should get us really nice and centered up on there. But again, I'm going to talk to the machine shop and see how it goes. Okay, so the end result is that our bolts all line up. So that's nice. It's already tapped for our clutch going around. And our clutch disc fits right inside to that little groove there. So that's pretty cool. So everything's looking pretty good for the flywheel. I'm going to take this to the machine shop and I'll be back. So we have our flywheel back from the machine shop. So this is what I came up with for the sizes. So what I did is, you know, we got our back surface to that front face, and we remember we need to be a 1/2 inch away from the face. So I came up with like a 1.075 to 1.08 is the finished edge. This surface here needs to be from the back surface underneath here, okay? So that's the number I came up with. And I also had them counterbore these holes in here because I'm going to be using ARP bolts. They have a little body on them, so then they have to go down into these holes. And then that, and I didn't end up, it was such a headache to try to get somebody to machine this that I didn't even ask about the dowel pins. I'm just going to use ARP bolts for here. So they machined the surface, and of course they machined it, and they machined it too low. Because even though I gave them a dimension, they just did whatever they felt like anyways. So how are we going to measure this surface right here? So what I did is I got a block of wood with a piece of plate, set that here. Then I'm going to rest it on that surface back here. This surface here will sit right on top of this plate like that. So then that gives us a flat surface right here to work on, to measure off of for that back surface. Took this, another straight edge, put that across onto there, and it sits on there perfectly flat and level. So we take our depth gauge like we used before. Then we could take this, come right over like that, and push it straight down. And that should give us our depth from the back surface to this machine surface right here. So then that gives us our number. We subtract the thickness of this, the same thing we did on the bell housing, or we subtract the thickness of that. But from this, and we came up with a size of 1.068. So it's actually smaller than the size that we want to hit our 1/2 inch. And I actually made this have more tolerance, a higher tolerance, so if they went too high on it, we would still have plenty of meat left on the flywheel. But of course they went down too low anyways. So if that number might be small, it might be not even important, but I didn't like how it was below what I think it should be. So what I did is I bought Chevy spacer. It's flywheel spacer shim, and it's 0.03 thick. And that's the part number there, 39100 from this company. So I'm going to use this as a spacer behind here just to move it out a little bit, because you figure the clutch is going to need some, if it was brand new or used, you'd need to have it in a good position. So if it, let's see, if it starts wearing out or anything, it doesn't end up being too far in. So that was my concern. So, okay, so the flywheel is good. It's done. I'm going to give it a cleaning, and we'll install this with our shim, and it should get us, actually get us a lot higher than that. So I put the flywheel onto the engine just to see what the distance is, just the way that it is, because remember, we want to have it to be a 1/2 inch from this surface, from the bell housing in, from the Scotty Adapter to here. So what I did is I actually ended up measuring it, and it was 5.515, which makes the flywheel go in this way too much, more than a 1/2 inch, which it may be not critical. This is maybe just, we're just talking about thousandths, so it may not be a whole lot. So what I did is I put the shim in, and it came up with the shim, it came to 4.75. So we're up closer to the face of the Scotty Adapter. So I'm going to run it with the shim just so I have some extra play, and we can adjust the clutch if we need to, but I'd much rather be further out this way than in further. You know what I mean? So that's what I'm going to do. We're going to go for that. So after all of this, we're going to install it all. Well, that's the end of the measuring video, and they're basically kind of measuring for guidelines or whatever for you to follow on your own swap or conversion. But congratulations to you. Drink yourself a lucky, and be happy that you made it to the end of the video, and I appreciate it. So thank you very much. Like and subscribe and follow along. The next step's going to be putting the engine in and the final installation of the engine, and then after that we're going to have to do all the other things to make an engine actually run. So thank you very much, and I'll see you in the next one. Bye-bye.